Hi everyone, my name is Ryon, and today I'm going to be presenting about my electric vehicle market game theory paper. So I'm a high school senior in Massachusetts, and some of the things I'm really interested are about economics, algorithms, current events, and things like that. So for me, it was a pretty easy idea to do game theory model research. So for a table of contents for my project, I'm going to start with an intro to game theory, then I'm going to go into a problem background, then a research question, the model, and finally my results. So what is game theory? It's exactly what it sounds like, and it's really of thinking of every situation as a sort of game with players trying to win. So game theory can have many applications, and you can use it in current events, economics, computer science, logic, and much, much more. So one really famous example of game theory is a prisoner's dilemma. And this is where you have two prisoners with two plea deals, and it's a simple introduction to how game theory works. So let's, kind of dive into it. So let's say you have two people who are in prison for committing a crime. However, now they are given the chance to take a plea deal and get out of jail early. So this is what's called a payoff matrix, and it shows the approximate jail times of each of the situations. So player A confesses and player B confesses, and they both try to take the plea deal. They both get 2 years in jail. If player A stays silent and player B confesses, or the other way around, the one that confesses gets 0 years in jail, and the one which stays silent gets 5 years in jail. And finally, if they both stay silent, they both get 1 year in jail. So the way you solve game theory and problems like this is by looking at outcomes one at a time. So let's say that player B confesses. Let's look at the best possible thing for player A to do. So it's pretty clear that the best thing for player A to do is to confess, as -2 or 2 years in jail is a lot less than 5 years in jail. And the same thing is true for the other way. If player B stays silent, again, it's in the best outcome for player A to confess, which means 0 years in jail in comparison to 1 year in jail. So in this situation, confessing is the best option, regardless of what the other prisoner chooses, and the same is true for prisoner B. So what this is called is a Nash equilibrium. So if both actors play the best that they can, knowing what the other actor wants to do or prefers, then they're reaching the Nash equilibrium. So the Nash equilibrium of the model that I just showed is when both actors confess and they both get 2 years in jail. So this is a huge part of game theory, and it'll be a really integral part of my presentation as I continue. So with that being said, let's dive into the problem background. So I decided to talk about the electric vehicle market because for me, this was a great combination of both current events, economics, but then also I could really apply game theory to it. So right now, electric vehicles are huge for climate change mitigation. And the more electric vehicles in use, the better it is for global efforts against climate change and against carbon emissions. So as a result, obviously, both the United States and China want to control the market and create the best possible electric vehicles. And despite the US having a head start, China is currently winning the race with newer and better electric vehicle products. So as a result, the United States has decided to tariff Chinese electric vehicles by up to 100%. And a tariff is basically a tax on goods shipped. And because of this huge amount of tax on Chinese goods, it's become a lot harder to buy Chinese electric vehicles. And it's creating a really dicey situation in the electric vehicle market where we could have a really closed off market and a lot higher prices. And even more so, China could retaliate with their own tariffs and their own sanctions against US products. So as a result, my research question was, how do we best keep the electric vehicle market open? How do we spread electric vehicles to the most amount of people? So I really tried to go about solving that through my game theory model and by finding Nash equilibrium. So here's the model which I created. And as you can see, it's a multi-stage model. The United States has an action, and then China has an action, and then the United States has an action again. So this is called a multi-stage game. And as you can see, there are 5 different possibilities which can occur based on how the United States and China, really approach the situation. But it's not really like an open and shut case to solve the Nash equilibrium for this model. Remember, everybody wins if electric vehicles are spread as climate change is mitigated. So you can't really just look at it and see, oh, the United States should do this or China should do this in order to win. So what I decided to do was use a third variable, which was a sort of a long-term or climate change variable, which really shows how the United States and China should look at the, bigger picture instead of just their own personal issues. So as you can see, this is now my model with two short-term outputs and one long-term output. So normally in game theory, results are shown with one actor and then another actor, like the United States, China. But in my model, what I decided to do was create three different variables: a United States short-term coefficient, a China short-term coefficient, and then a long-term variable which applies to both of them. So this is a better representation of the current situation, but it also means it's a lot harder to solve. So as you can see, these were the values that I decided over the course of my research and realizing what the United States and China preferred. So I got these values, and below is the table form of this. So how can we solve it? And that was a question which really took up a lot of my time. But suddenly I realized that it's really important to be using a weighted average to try to find these three variables and condense them into two. So what I decided to do was use two constants, or the prudence constant, for the United States and for China. And this is a variable which really determines how much they care about the future. And it's a value between 0 and 1, and I'll be weighting their short-term coefficient and the long-term coefficient by it. So in step 3, you can see the formulas for both the United States and China. And what I decided to do was take many different possibilities of p-values and then find the Nash equilibria for all of these different situations. So over the course of my project, I've actually did more than 20 models, but here are three of some of the most important models which I use. So in the first one, you can see that PU is equal to 0 and PC is equal to 0. And I found that the Nash equilibrium is the United States increasing the tariff and then China responding. Then I have P is equal to 0.8 and PC is also equal to 0.8. And in that situation, the United States does nothing and China does nothing. That's the Nash equilibrium. And then finally, I have PU is equal to 0.6 and PC is equal to 0.2. And in that situation, there's yet another occurrence which happens. So as you can see, at different PU and different PC values, very, very different outcomes occur. So over the course of all my research, I tested 20 to 30 of these possibilities, and I actually managed to find a table which shows the Nash equilibria in each of these situations. So in the top, you can see a color-coordinated map of each of the possibilities, with, again, the green scenario being the optimal scenario, the scenario which is best for the world. So as you can clearly see, this happens when PU is greater than equal to 0.2 and PC is greater than equal to 0.4. And while these results might seem pretty good, this also means that there's a large range of values where suboptimal outcomes occur and where the electric vehicle market becomes a lot less free. So with that being said, here are my conclusions. One thing which is really important to discuss is that the model is slightly arbitrary. I came up with the values myself, and even if the relative values are true, PU and PC aren't definite. You can't just tell the United States, oh, make sure you keep your PU value above 0.2. They'll be very confused and not really understand what that means. So the way I really tried to find my conclusions were more of seeing how the United Nations and how international bodies can shift the games, how we can increase values such that the United States and China use the optimal scenario a lot more. And some ideas I had for this include like leadership roles, decreased monetary commitments, in an effort to increase the values in that way. So for example, here's my model. And initially you have that it's 0, -5, and 50 for the United States and China. But let's say the United Nations, through international cooperation, could increase these values to 20, to 15, then 50. And if that was the case, the United States and China would be a lot more incentivized to go towards the scenario most optimal for international electric vehicle market, as well as climate change efforts. So with that being said, thank you, and it's time for questions.
Awesome. Wow, that was very interesting. I've never understood that before, so thank you for explaining it so eloquently. So you mentioned at the end that, the UN could kind of get involved and step in to help enforce this. Do you feel like this is something that other countries should kind of get involved in as well? How do other countries other than the US and China have to do with this?
Yeah, and that was a part which like a consideration which I really thought about a lot during the course of my research paper. How can countries like the EU or organizations like the EU or countries like Japan and Mexico also play a role? So obviously the United States and China, the decisions that they make apply very largely to these other organizations and countries as well. So really what I was thinking for in terms of conclusions was a way to make sure that these other countries and international bodies can make sure that the market is kept the most free and like really put aside personal like economic squabbles and really focus on international climate change efforts. So yeah.
Gotcha. So like every country, don't do anything. Keep it free.
Yeah, and it's very like, um utopian scenario, but that's really what's necessary in order to find the best and most open electric vehicle market for the future.
Yeah, that makes sense. Are you planning to do anything with this information?
Yeah, so I wrote a research paper on it, and yes, I've submitted my research paper, and I think that it's really important to like, get into contact with your local officials and local like representatives, senators, and really make sure that they focus on really putting like playing a large role in helping international emissions efforts, specifically through electric vehicles in this case.
Yeah, yeah. And do you know if like, how likely is this scenario to happen?
So actually what is happening right now is the United States put in these sanctions in, I think it was March or April on China. And really thankfully, China hasn't responded to them. So I think right now what is occurring is that China isn't responding and the United States probably won't increase EV sanctions. So that's the scenario that I was really hoping for. And my model was really attempting to go towards. So I think right now what we're looking for is occurring, like, knock touch on wood. So